Many Rust developers think async automatically means parallel, but this exact same async program can run on one CPU core or all your CPU cores. And the only thing changing is the Tokio runtime. If you have written async Rust using Tokio, you have probably used this macro like Tokio and main. But most developers don't realize this macro actually configures a runtime. Tokyo provides the two main runtime types. First one is current thread runtime and second one is multi-thread runtime, and they behave very differently. So now let's talk about current thread runtime. To implement current thread time, we have to do something like this. So this runtime runs everything on one thread, uses cooperative scheduling, and tasks share the same executor. This means tasks are concurrent but not parallel. Now let's talk about multi-thread runtime. This runtime creates, for this runtime we'll discuss three things only. It creates a thread pool. Second thing is schedules tasks across multiple CPU cores. And the third thing is it enables parallel execution. So to implement multi-thread, we'll do something like for instead of current, we'll just pass multi. So by this, we can uh, use multi-thread CPU cores and multi-thread execution. To see both threads in action, we have created a simple program that spawns multiple tasks, and now we spawn several tasks in our main function. This program is identical in both examples. The only thing we change is the runtime. So, uh, so uh, implement. Let's use this function in our main.rs. We'll loop through uh, for Tokyo spawn, and we'll wait for uh, 3 seconds, I guess, and we'll await it. Now we'll run our program in both threads. First, we'll start with current thread. So let's implement current thread, and now we'll run our program. So let's run our program. When we run this program, notice something interesting. Every task prints the same thread ID. All tasks are sharing the same thread. So even though the program is async, it's not parallel. So now let's change the runtime. Now we'll implement multi-thread. Uh, so now we have implemented multi-thread, and now we're going to run our program again. So as you can see, uh, now tasks are distributed across multiple threads because thread IDs are different. This is called true parallelism. So what's actually happening behind the scene is, let me explain you by this. So that because we have run our same program in both of the threads, single thread and multiple thread, it distributes something like this. As you can see, for multiple threads, it utilizes multiple CPU cores. so which allows our program to run and take advantage of true parallelism in action. Async Rust gives you concurrency. Tokyo's multi-thread runtime adds parallelism. This is crucial difference when optimizing performance. So when to use which runtime? Use current thread when embedded systems are involved deterministic execution and very lightweight workloads. And as for multi-thread, use multi-thread when high through output servers are involved and network services are there and CPU IO workloads are there also. Most production async Rust servers use multi-thread runtime. Async Rust does not automatically mean parallel execution. The runtime decides how your tasks run. And understanding this difference is essential when debugging performance in async system.